Today we're looking at equations that have the form sine theta is equal to cos theta. So what we need to do is we need to learn to recognize these equations because they have a special way of solving them. So when you look at an equation, if you have sine and cos together in an equation, so say sine x and cos x together, and the angle is the same. So in other words, this x must match with that x. That would imply that the angles are the same. You can't have an x with a 2x. You can't have a theta with a 2 theta. Okay, these are not the same angles. You've got to have exactly the same angles. And the other thing we have to look for is that there's no constant term. Okay, so when I say no constant term, I mean that we couldn't have sine x plus cos x is equal to 4, because this 4 is a constant term. So it's not the right form. Okay, there can be no number term. Only a 0. You can have a 0 there. So if it was say sine theta is equal to 4 cos theta, that would be fine. All right, because you don't have a number only term. You have a 4 times cos theta and your angles match here. So my angles are both theta, they match. And there's no number only term. All right, so this one is going to work with what we are about to see. Okay, so that's what we need to look for. Angles are matching, you need a sine and a cos, and you can have no number term. All right, so let's look at what we do when we see this. All right, so this says determine the general solution of sine theta is equal to negative cos theta. So I check my equation. Okay, do the angles match? Yes. They're both theta. Okay, so we've got matching angles. Is there a number only term? No. Okay, so again, we've got everything set up. Angles match, no number only term. So what we do with these is we go through these steps. Step 1, we put sine on the left-hand side and cos on the right-hand side. Okay, and in this equation, it's been done already. You can see you've got sine on the left-hand side and cos on the right-hand side. So after that, we divide both sides by cos theta. And you'll see why now. Okay, so it's always the same. We always divide by cos theta, and this is why. If we take sine theta is equal to negative cos theta, and we divide both sides by cos theta, can you see that the right-hand side here now, sine theta over cos theta, do you remember your identities? This was going to change into tan theta, and that's what we want. We want to make it simpler. So the third step is to change your sine theta over cos theta into tan theta. All right, so you have to divide by cos to get sine over cos to change it into tan. All right, so this is going to be tan theta. And on the other side, what will happen is that this will divide into their ones and ones, and you're going to get negative 1 over 1, which is negative 1. All right, once you have done that, it is exactly the same as the equations we started the section with. So it's a nice, easy equation. So we're going to now solve as usual. So how do we solve an equation? First step is to isolate the trig ratio. So get it by itself on the one side. And this is already done. Tan is alone on the right-hand side. All right, and then we check our sign for the quadrants. Right, so tan is negative. Where is tan negative? It's negative in 2 and 4. Okay, tan negative, 2 and 4. And then we find our reference angle. Okay, so theta is going to be, tan minus 1. And then remember, we don't include please don't include the negative and the reference angle. It's just positive 1 there. All right, and then when we work that out, we would get theta is equal to 45 degrees. All right, so now we've got to continue. We said quadrants 2 and 4. So 2 and 4. Okay, quadrant 2 is 180 minus your reference angle. 360 minus your reference angle for quadrant 4. All right, so theta is going to be 180 minus 45 plus k lots of 360, or theta is going to be 360 minus 45 plus k lots of 360. This is all the same as your basic equations. So this is going to be 135 plus k lots of 360, and this one's going to be 315 plus k lots of 360, and remember k is an element of z. Okay, so that is a general solution to an equation that has sine and cos together, angles matching, and no constant floating around. Okay, so let's look at another one, number 2. All right, so let's check it. Do we have sine and cos with matching angles? And they both got an alpha. Okay, so there's an alpha there and an alpha there. Okay, then we say, is there a constant term? In other words, a number-only term. And there isn't. That 0 is fine, okay? We said we could have 0 there. That's not a problem. There isn't a 1, a 2, a negative 3 floating around, okay? All right, so because those two things work, sine and cos together with the same angles, no constant term, we then start our steps. What do? We put sine on the right-hand side and cos on the left-hand side. Right, so in this one, my cos is in the wrong place. It's on the on the left-hand side still. So I'm going to subtract. It's a +4, so we do the opposite, inverse operation. So we minus 4 cos alpha to make that into a 0, make it disappear. And what we do to one side, we do to the other side. All right, so we've done that. So let's write that down. So 3 sine alpha is equal to negative 4 cos alpha. All right, so now I'm sorted. Sine on one side, cos on the other. All right, now what do? We divide both sides by cos. And it's obviously got to be cos alpha because it's an alpha in the sum. So we divide the right-hand side and we divide the left-hand side by the cos of alpha. All right, and the reason we do that is so that we can change the sine alpha over cos alpha into tan alpha. All right, so I'm changing the sine over cos into tan. So this here is going to change into tan. But can you see the 3 still waiting in the front there? So it's going to be 3 tan alpha is equal to, and on this side, cos alpha and cos alpha cancel, and you get negative 4. All right, so now we're back to solve as usual. And what do? We isolate the trig ratio, which means in this case, we've got to divide both sides by 3 to get that tan alpha alone. Okay, so we got tan alpha is equal to negative 4 over 3. All right, next we're going to check your quads from your sine. All right, tan is negative in quadrant 2 and 4. All right, and then we find our reference angle. And remember the reference angle, we're going to be using tan minus 1 and no negative in your reference angle. Okay, very important. So alpha is going to be tan minus 1 of 4 over 3, or arctan I should say, sorry. Probably got maths teachers rolling around. And we have 53,13. Okay, so this is my reference angle. Reference angle. Oh, no, I shouldn't be underlining that. I'm not done. All right, so where am I going now? I said I had to go into quadrant 2 and quadrant 4. Quadrant 2 is always reference angle subtracted from 180. So 180 minus 53,13 plus k lots of 360. And this is 360 minus 53,13 plus k lots of 360. Okay, so get these like terms together here. 180 minus 53.13. 126,87 plus k lots of 360. And this one is going to be 306,87 plus k lots of 360. And remember, k has to be an integer if we are finding a specific solution, but in this case, it's just your general solution. All right, so the last part is exactly the same as a normal trig equation. You just have to remember, do you have sine and cos together? Do the angles match? Okay, sine and cos together, same angles. No squares floating around. So just sine, just cos, and only allowed a 0. No other constant term can be floating around there.